Now, if we come back to this interface here, the question is, why do we need this? Wouldn't we have the exact same thing if we would add a custom type here? And there, the difference is just that we have to add an equal sign. And then we're saying the person type is an object which looks like this. And indeed, if we save that, it compiles without errors. So we could replace our interface with such a type, and it works as before. So why do we have an interface then? Well, an interface and a custom type are not exactly the same. Whilst often you can use them interchangeably and you can use an interface instead of a custom type or the other way around, there also are some differences. Well, one major difference is that interfaces can only be used to describe the structure of an object. You can use type for that as well, but inside of a custom type you can also store other things, like union types and so on, what we did earlier in the course. That sounds like type is therefore more flexible, but the other side of the coin is that interface is clearer. When you define something as an interface, it's super clear that you want to define the structure of an object with that. And indeed, when it comes to defining object types, you more often see interfaces out there in the wild than you see custom types. Now, another thing you can do with interfaces, but you would also be able to do with custom types, is you can implement an interface in a class. What do I mean by that? The reason why you often work with interfaces is that an interface can be used as a contract a class can implement and a class then has to adhere to. Now, what do I mean with that? Let's say our interface is not a person interface with a name and an age, but instead we name it greetable. Now, this might look like a strange name, but in the end, this just says any object that should be treated as greetable has to be an object with a name and with a greet method. So now we could say this here, this user1 variable should hold a greetable object. And of course, now we get an error because we have more than just name and greet. But we could use this interface to share it amongst possibly multiple classes. We have to ensure that every class that adheres to this interface has to have a name property and has to have a greet method. So here we could now add a person class. The name is available again because I renamed the interface. And now tell TypeScript that this class should basically adhere to this interface. It should implement this interface. It should follow that contract set up by this interface. We do this by adding the implements keyword after the class name and then the name of our interface, greetable. And you can implement more than one interface. That's a difference compared to inheritance. You can inherit only from one class. You can implement multiple interfaces by simply separating them with a comma. So there we could have another interface if we had one. Here I only have one though. And now the implication of this is that we get an error here because our class incorrectly implements the interface. It does not have the name property, it does not have the greet method. So now we have to set this here in our class, maybe also add a constructor where we get a value for the name and then set it up like this, and where we also add our greet method, where we then might have this logic from down there. Now in our class, we can have more than that. We can have more fields, we can have more methods, we can also extend this class, we can work with this class as we always can. But we're forced to implement this method correctly, to have this name property, because we're implementing this interface. And therefore, interfaces are often used to share functionality amongst different classes, not regarding their concrete implementation. You can't have implementation or values inside of interfaces, but regarding the structure, regarding the features a class should have. It's a bit like working with abstract classes, therefore, the difference being that an interface has no implementation details at all, whereas abstract classes can be a mixture of you have to override this parts and I have a concrete implementation parts. That's an important difference between interfaces and abstract classes. Now with that, however, we have our person class here, and now here, user1 can be created by using new person and feeding in the name, for example. And now you see it's okay that we have this age here in user1, because we build user1 based on person. Person implements greetable, and you can add more than greetable once in a class, but you have to satisfy the conditions set up by the interface. And therefore now if we save everything, we have a valid code, and if we log our user1 down there with console log, we see that it is a normal object with an age and a name in this case, but the key takeaway is that it is based on a class which implements the interface. And you can then also use the interface as a type. Of course, we could have set this to type person, but as you see, using type greetable here also works because the person object, which we store in the user1 class in the end, is based on the greetable interface. It implements this. So that's another powerful feature. You can use an interface as a type on some constant or variable, which will then actually store another class of another type, which in turn is based on the interface type because it implements it. So that's interfaces in a nutshell. A lot of powerful features included.